this video, I want to use the classical approach of calculating probability to find the probability that I get 3 heads when I flip 3 fair coins, or if I just flipped 1 fair coin 3 times. I have a quarter, a nickel, and a penny here to help me out, but I want to start by reminding us what the classical approach is. We need to have some number of simple event outcomes that are equally likely. Well, if I flip 1 coin, I can get a head or a tail, and that's equally likely. When I flip 3 coins, well, there are a number of different possible outcomes, and we need to figure out what they all are. But the way to calculate the probability is to calculate the number of ways in which the event we're talking about here, 3 heads, happens, and divide by the total number of simple event outcomes. So again, I want to know the probability that when I flip those 3 fair coins, I get 3 heads. When you're writing down a probability statement like this is a probability of 3 heads. The event we're talking about goes into parentheses. The probability we're calculating, well, we'll write that out here as a fraction, and then maybe even as a decimal rounded to 3 decimal places. Well, to start out, I want to think about flipping just one of these coins. And so, when I think about the quarter, when I flip it, I can get a heads or a tails. And so I flip it, and then I see what it is. And at that time when I flipped it, it came up tails, but I could imagine just as easily that it would have come up heads. So after I flip that, I get a heads or a tails, and I know those are the only 2 possibilities. So now I go on, I want to imagine that I flip the nickel. And that time I got a heads, but I could imagine I just as easily could have gotten a tails. So if I had gotten a heads on that quarter, the nickel could have come up either heads or tails. And if I had gotten a tails on the quarter, then this still could have come up heads or tails. And at this point I recognize that there are really 4 possible things that could have happened so far. I could have gotten 2 heads, I could have gotten a heads and then a tails. I could have gotten a tail first, then a heads, and then 2 tails. Those are the only 4 things that could have happened at this point. And now I flip the penny. And again, I can get a head or a tail, but I have to imagine that if I had gotten 2 heads in a row, the penny still could have come up heads or tails. If I'd gotten a head and then a tails, the penny could have come up either heads or tails. And then for all of these options here, the penny still could have come up heads or tails. This is what we call a tree diagram. And if I follow the tree diagram from the beginning to the end of a branch, I have one event in the total number that could happen. So I want to write down all the possibilities for when I flip these 3 coins. I'm using a curly bracket here because this is going to be a set of outcomes. We like to use curly brackets in mathematics when we're describing sets. And more than that, I'm going to write down every possible simple event outcome. And when we do that, what we're doing is writing down what we call a sample space. A sample space is when we write down every possible simple event outcome. So this first one, head, head, head. Alright, so I've gotten that one. Next up I would have head, head, tail. Head, tail, head. And again, I'm just traveling down every possible way I can navigate this tree diagram. So I have head, tail, tail. Alright, so I'm halfway through, and now I will have a tail, head, 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 tail, 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 head. Kind of writing off the board here, so we'll scoot that up just a little bit. So that would have been tail, tail, head. And then finally, tail, tail, tail. If I look at the bottom of my diagram, I should have 1, 2, 3, 4, 5, 6, 7, 8 possible things in this sample space. I have 1, 2, 3, 4, 5, 6, 7, 8. Corresponding to those 3 flips of these fair coins. And again, it wouldn't matter if I was flipping the same coin 3 times, just for purposes of example, it's nice to have the 3 different coins to think about. All right, but then I was asked for the probability of getting 3 heads. So I look at my sample space, and on the bottom of a classical probability, I think about the total number of things in the sample space. So there are 8 things in that sample space. And then on top, the number of times I see 3 heads, and I only see that one time. If I flip these 3 coins, there's only a 1 in 8 chance that I get all 3 to be heads. Well, let's see what happens. Well, I ended up with 3 tails, and that's just as unlikely. If I look at my tree diagram, there's still 8 possibilities, and only one of them is all tails. So it's a 1 in 8 probability, a 0.125 probability. Oh, let's just flip them one more time and see what happens. This time, I get a tail, a head, and a head. And if I think about this tree diagram, this was about the quarter, the nickel, and then the penny. So if I was looking for that, I realized that in that order, I have a tail, head, tail. So that's this one. That only happens one time. Now, if I relax the question, and I don't worry about which coin is which, and I ask, what's the probability of 2 heads? I just look through here and I see anywhere I see, and I'm thinking about exactly 2 heads. I look through for anywhere I see exactly 2 heads. Well, that's not it, because that's 3. But here I have exactly 2, 2. I only have 1, 2, 1, 1, 0. So that would be a 3 out of 8 probability. After I've written down the sample space, we can answer all kinds of questions about this situation.